Hi, welcome to another video. Today we're going to be looking at probability. So we're going to sort of start looking at this as a new topic. So just an introduction today into probability, just some definitions of what certain things mean. So let's get started. So firstly, sample space. So what the sample space means is basically a list of all the possible outcomes. So as an example, if you roll a dice, then we have the set of 1, 2, 3, 4, 5, 6. That's just a standard dice. So that would be the set, the sample space for rolling a dice. If you flipped a coin, it would be heads and tails. So it's just basically a list of all the possible outcomes. So that's sample space. Complement of event is everything other than the event. And so if you said that A was, if we go back to the dice, odd numbers, rolling an odd number, then the complement of A, which we have as A dash, that's how we write the complement, would be rolling the even numbers. Okay. If B was, on a dice, was rolling a number that was bigger than 5, so rolling a number bigger than 5, then the complement of that would be rolling a number that was less than or equal to 5. Okay, so it's everything other than that result. Hope that makes sense. That's the complement. And just to add a formula in there, if you're trying to find the probability of a complement, that's simply because it's everything other than that. It's 1 take away the probability of its complement. Okay, so there's a formula for if you're ever trying to find the complement of something, 100% take away that. So that's a quick way there. This is something that students learn from, year sort of, 6, 7 upwards, finding the probability. When you're finding the probability of something, you just find the number of ways that that event can happen divided by the total possible outcomes. So if you're rolling a dice, you want to know what's the probability of rolling a 2. There's one way that that can happen, and there's 6 possible outcomes for a dice, so it's 1 over 6. So that's simple. Everyone understands that. That's a simple concept. If you want to know what's the probability of rolling a number bigger than 4, then there's two numbers, 5 and 6. So it's 2 on the top line. 6 possible outcomes, so it'll be 2 over 6. I think everyone is all okay with that. All probabilities are between 0 and not between. Probabilities are greater or equal to 0. They can be equal to 0 or less than or equal to 1. Cannot go outside of that. All probabilities are between 0 and 1. 0 means impossible. 1 means certain. It definitely does happen. This here, that might look like gobbledygook, but what that means is if you add up all the probabilities of all the possible outcomes, then you'll get the number 1. So, if you go back to the dice up here, if you add up all the probabilities of those dice rolls, you get 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 will equal 1. For the dice, heads and tails, you get 50% for the heads and 50% for the tails, and so half plus a half is 1. So you always, when you add up the probabilities of any event, then you'll always get the number 1. This symbol here, that horseshoe, that is an intersection. So that shape there, that means and so what will often happen is you'll see A intersect B. And what that means A and B. So both A and B are true. And if you draw a sort of Venn diagram to sort of show that situation, if that's A and that's B, then the A and B is that area in between, in the middle bit. That's where both A and B are both true. The union is sort of like I'm not going to say the opposite of that because it's slightly different, but union means or. And if you think about that A or B, if you think about what sort of event could be A or B, not quite enough space for myself here, A or B, then that space is anything, maybe I'll use a different pen here. So it's anything in there. Okay, so any of those areas there. You'll see that anything coloured in red is in A or it's in B. And so or is dictated by that space there. That's the union coming together. Independent events. Now, this is something that students find a bit tricky. I think teachers find this a bit tricky. So independent events are two events that have no influence on each other. Okay, and so two events that might have, if you roll a dice. So if you've got a dice and you roll it once and you get a 4, when you roll that again the second time, it has no influence from roll to roll. It doesn't matter what happens. The dice has no memory. It doesn't know what happened. So those two events, one dice roll and then rolling it again, they would be independent because there's no influence from one roll to the next. What would be something about dependent events? Well, if you had, like, say, a cup and you had, let's go, 2 blue coins, 3 red coins, and 1 green coin. Let's say that, and you were trying to find what's the probability of pulling out a blue, right? At the start, if you're taking out the first one out of there, the probability of taking out a blue will be 2 out of 5, 2/5. That'll be the probability the first time. Now, if you don't put the blue coin back in, then the second time you do it, the probability of pulling out a blue will be different. So it'll be dependent on what comes out the first time. If a blue came out the first time, then the probability will be 1/4, because there's only 4 things left and there's only 1 blue. And if it was not a blue, that would mean that there's 2 blues left in out of 4. Then you get a probability of 2/4. And so you can see that that is dependent. So because, we need to know what happened on the first roll, that influences the second roll, that would be dependent. So let me just write that here. That's dependent. That one is independent. So you need to look at from one event to the next event. Does it have an influence on what happens next, on the calculations, what happens next? Hope that makes sense. It's a really key concept, independent events. The last concept I want to cover in this video is mutually exclusive, which you really need to understand the difference between that and independent. Mutually exclusive actually means two events that have nothing in common, okay? And if you draw it as a Venn diagram, what does it look like as a Venn diagram? Whoops, that is not what it looks like as a Venn diagram. What it looks like as a Venn diagram is this. So you got event A, event B, and you can see that all the possible outcomes of event A are totally separate from the outcomes of event B. They have nothing in common. An example of this would be if you roll like the dice that we said before, and if event A was rolling a 2 and event B would be rolling an odd number, you'll see that those two events, they will never happen together. There's no way, there's no intersection there. You can't roll a 2 and roll an odd number in the same event. They've got nothing in common. Their outcomes are totally separate, and that's what's meant by mutually exclusive. That's all I wanted to cover in this video. Hopefully all those concepts there, so these are like the foundations of probability. So if all of those make sense, then you can sort of build on those as you keep going through. Hope that makes sense. See you in the next video.